And this is exponential and logarithmic equations. We have two separate examples. So this is covering examples 1 and 2. Example 1 here, 2 in the red. The first one, solve 7 to the 3x equals 20. Now when we've solved exponential equations before this, our goal was to get the same base number, and then it was easy to solve. For example, if we had 3 to the x equals 9, you can change the 9 to what? 3 squared. So you have 3 to the x equals 3 squared, so you know x is 2. If you can get the same base number, that's what you want to do. Makes it easy. But in these problems, you can't get the same base number. There's no common base between 7 and 20. So we have 7 to the 3x power equals 20. So what we want to do here, if you do something to one side of the equation, you have to do it to the other side. You can do anything you want to one side, as long as you do it to the other side, it won't affect the problem. It won't change the problem. So if I throw a log in front of both of these, it's not changing the problem at all, because I'm doing it to both sides. That's what I'm going to do. If I can't get the same base number, just put a log in front of both of them. Now you use your properties that we used the other day. What do I do with the 3x?
Put it in front.
Yeah, use the power property, it comes to the front. So we have 3x log 7 equals log 20. Now all you had to do is get x by itself. Divide both sides by log 7. You have 3x equals log 20 over log 7. At that point, you need your calculator. So get out your calculator and you will type that straight into your calculator. We don't have a base number, so we're okay. So you would type in log 20, just like I have up here. Log 20 divided by log 7, and you end up with 1.539 and so on. And then I had to take that result, since it was 3x equals that, you had to divide by 3, and here's your final answer, 0.5132. They carried it out to 4 decimal places.
Can you redo that?
I'll do it again over here in the next example. Okay? Make sense? Alright, so let's look at the next example. It says to solve by graphing, but if you like this method, just do it like this. It's a lot easier than graphing. So the red wants you to solve by graphing, but again, just do it like we did over here. Throw a log in front of both of them. Power property of the 2x comes out front. Divide both sides by, I left out the 6 here, log 6. So in your calculator, we would do log 1500 divided by log 6. And that's what we get, 4.08 and so on. But then it was 2x equals that, so I had to divide by 2. And that's what you should get, 2.0408, which is what I did get right here. Does that make sense? Okay, so we're not doing much except throwing logs in front of both of them and solving from there. Good. All right.
That's a 0. That's a 0
Wait,
from
would
the
you
board.
want to say something else?
Whoa, say that one more time.
That's a 0 from the board.
Right here?
Yes.
Where?
In front of the board, in the bottom of the.
Yes, this is 0. Okay? Next, solve here. Now what you want to do here is get the exponential part by itself. So that's why I divided both sides by 2 to start with. The original problem was 2 parentheses 1.5 to the x power close parentheses equals 6. That was the entire problem. So the first thing I did was get rid of that 2 by dividing both sides by 2. So you're left now with 1.5 to the x equals 3. And then you do the same thing that we did in the first two examples. Throw a log in front of both of them. Using the power property, the x comes in front. Then just divide by log 1.5. In this case, we stopped at the second decimal place because it told us to round to the nearest hundred. So all I do is do log 3 divided by log 1.5 in the calculator. And you should get 2.71. If you want to check that, go for it. So the only thing new here in this example is you have a number in the front that you have to get rid of. Did you get it? 2.71? Who tried it? Get 2.71? Okay, good. Log 3 divided by log 1.5.
Isn't that just log 2?
All right. Moving on. Write down this formula to the right. Change the base formula. We've talked about this. The calculator understands the base number to be what? 10. Okay? So if you have a base number other than 10, you weren't able to do it up to now. But now we have a change of base formula, which is right here. Log base A of B equals log B over log A is how you would punch it into the calculator. The base number, the log going with the base number always goes in the denominator. The larger number goes here. Okay, so if I have log base 3 of 15, you couldn't evaluate that even if you put it in exponential form, like you were taught. You would put it 3 to the x equals 15, but you don't know what x is. If you had log base 3 of 9, you should know it's what? 2, because 3 squared is 9. So to evaluate this in the calculator, use the change of base formula. You would have log 15 over log 3, which comes out to be 2.4650. Same thing here. Change of base formula. Log base 5 of 400 equals log of 400 over log 5 is how you would punch it into the calculator, which comes out to be 3.7227. Question? Okay?
Can you not move it?
Yeah. All right. So now you know how to solve these using the calculator.
Okay.
All right, now the next one, solve this equation. Solve. Log of 3x plus 1 equals 5. If there's not a base number, it's understood to be 10. Okay? So the first thing you do here is get rid of the logarithm and change it to exponential form. Smiley face, 10 to the 5th equals 3x plus 1. And once you get there, you should be set. 10 to the 5th is 100,000. Equals 3x plus 1. Subtract 1. 99,999 divided by 3. 33,333. Easy enough. So in these, just make sure you understand that the base number that's not there is 10. And change it to exponential form just like we've been doing. And one more. Everybody got that one now? Okay. Alright, here when you solve this equation, when you solve logarithmic equations, you can't have logs showing up more than once. So you got to use your properties of logarithms to condense. So the first thing I do, if I have a number in the front, using the power property, where does it go? It goes up to be an exponent, as x squared. What property goes with subtraction? Division. So I'm going to condense this side to one logarithm, make it log of x squared over 3 equals 2. Are we good up to here?
Wait. No.
No, I'm confused
Okay, where?
with the whole.
You understand how the 2 came up?
Because the exponent,
Power
yeah.
property. And subtraction, what goes with subtraction? Division. Put these two together and divide them.
Okay.
And make it one logarithm. Now, just like we did in the previous problem, what's your base number?
10.
10. So put it in exponential form. 10 squared equals x squared over 3. What is 10 squared? 100. And when you cross multiply in this case, you get 100 times 3, which is 300, equals x squared. Question so far? Okay, at this point, to get rid of the square, what's the opposite of squaring? Square root both sides, so I take the square root of 300. What's a factor of 300 that's a perfect square? 100 times 3 was square root of 100. So your exact answer, if I asked for the exact answer, it would be plus minus 10 root 3. You gotta put the plus minus. If I asked for the approximate answer, it would be plus minus 17.32. You would just type this straight into your calculator. Square root of 300 and get that. Okay, so the only thing new in this, the only thing different from this example than the previous one was you had to do some condensing before you got to this point. Okay, but I think once you get here, you should be set.